All right, so we're going to graph a log function here, okay? And before I get into graphing this whole piece here, there's a lot going on, and I went with one a little bit more complicated. So let's start with a couple first facts here. So one, of all your log properties, we're going to recall that the log base b of b is equal to 1. All right, so for example, log base 5 of 5 is equal to 1. Log base 3 of 3 is equal to 1, right? So that's the property I'm referring to. Second one I'm going to refer to is log base b of 1 equals 0. So, and then for example, if this was just log base 3 of 1, that's going to equal 0. And if I think about this exponentially, this really means 3 to the 0 power equals 1. So anything to the 0 power is going to be 1. Right? So that's the next one I'm going to use. And then the third one I'm going to use or think about is the log base b of 0 is undefined. And what happens is we're going to get a vertical asymptote here. Okay, so your log function will have a vertical asymptote. All right, so we're going to use these three properties and I'll pick them apart one by one. So let's take these first. Let's take this first one. So any log function I have, right, and what I'll do is I'll just look at the log of 3, okay? So if I take, for example, log of 3, log base 3 of x without the x minus 1, well, if I make this log base 3 of 3, then my answer is going to be 1. What we have is log base 3 of x minus 1. So what would x have to be in order for x minus 1 to match its base? Right? I want this to equal the base. So if you think about this, x would have to be 4, right? Because 4 minus 1 is equal to 3, and that's the base of my log. Okay, so now I'm going to use that. So one x value I'm going to use right now is x is equal to 4. All right, so one more time. Or think about this one more time, okay? So if you take the log base b of b, log like this one, log base 3 of 3, it's equal to 1. So my answer is going to come out to 1. What I'm trying to do is get all this equal to become 1. So how do I make this? So then I could just do negative 2 times 1 plus 4. So how do I get this all equal? How do I get log base 3 of x minus 1 equal to 1? Well, I would have to take, in order for that to happen, this would have to be negative 2 times log base 3 of 3 plus 4, right? Because the log base 3 of 3 is equal to 1. Okay, so let me back up another step here. So how do I get negative 2 log base 3 of x minus 1 plus 4 to be 3? Well, that means that x would have to be 4. So if x is 4, then I can use the property of log base b. Then I can use this property, because then I'll have log base 3 of 3. All right, and then the rest is just multiplication. So this becomes negative 2 times 1, which is negative 2 plus 4, and I get a final answer of y is equal to 2. So one coordinate is going to be when x is 4, y is 2. And we're going to graph all these. The next one I'm going to use is my second property here, which is going to be very similar to what I just did. But this time, I don't want log base 3 of 3. I want log base 3. I want log base 3 of 1. So there we go. So I'm going to drag this over to the side. Actually, we'll leave that. So y equals negative 2 log base 3 x minus 1 plus 4. Okay, so I'm trying to get to y equals negative 2 log base 3 of 1 plus 4, right? And that 1 is going to allow me to use that property. So how do I get that to be 1? Well, this is negative 2 log base 3 of something minus 1 plus 4. So what must that x value be here in order to get 1? And that's going to be 2. Right? Because 2 minus 1 is 1. Right? So I'm looking for those values. So in this case, x is going to be 2. So if I plug in 2 for x, then I'm able to get 2 minus 1 and get 1. So this is negative 2. Right? If I continue this further, log base 3 of 1 is equal to 0, right? That's this property here that I'm using. Property number 2. Right, sorry, this is 0. And then plus 4. Right, so log base 3 of 1. So this log base 3 of 1 here is using this property here. And then negative 2 times 0 is 0, and 0 plus 4 is 4. So when x is 2, y is 4. That's my second coordinate. And then I'm going to use the last property here, the log of 0. So I'll do this one here. So I've got y equals negative 2 log base 3 of x minus 1 plus 4. And again, my goal here is to get negative 2 log base 3 of 0 plus 4. So let me back up a step. Negative 2 log base 3. So what's the x value that has to go in here to make that 0? To make the next step, make this whole thing equal to 0. And x here would have to be 1. Right? And then here, once I get log base 3 of 0, then this is going to be undefined or error on your calculator. This is pretty much where you have your vertical asymptote. So your vertical asymptote is at x equals 1. All right, so let's put a couple of these things together. So here's my graph. So here's x, here's y. First coordinate we have is 4, 2. So 1, 2, 3, 4, 2. The next coordinate we have is 2, 4. 1, 2, 1, 2, 3, 4. And a vertical asymptote at x equals 1. Okay, so right now you have those two coordinates. Now, just to bring you back a few, an exponential function looks something like this. The logarithmic function is the inverse, which looks something like this, right? And they're going to look, but they're all going to have that general shape, right? It's like the half of u, whatever, but exponential and log functions are going to have that general shape there. So you could get a couple more coordinates here, but for the most part, this graph is just going to go down and follow this path and come down and eventually cross the x-axis somewhere, but it's going to follow this path here, right? But let's try to get one more point and see if we can get another idea of where we're going. All right, so to get one more point, I want you to think about some things like this. I want you to think about if you take the log, and we have log base 3 here, log base 3. You want this to be a number that's something in reference to 3 to some power. So 3 to the first is 3. So 3 to the first is 3. So log base 3 of 3 is equal to 1. Right? And if we have 3 to the second is 9. So log base 3 of 9 is equal to 2. Right, so there's my exponent. There's my exponent. 3 cubed is 27. So log base 3 of 27 is equal to 3. Right, so it's 3 to what power is 27. And you have a couple numbers there. So when you have this equation of x, log base 3 of x minus 1, so you have negative 2 log base 3 of x minus 1, and then it was plus 4, plus 4. What I want is I want this to equal one of these numbers. Right, so we already did the first one. We already got with the base because that was one of the properties I used. So let's use another one. Let's get this equal to 9. Because then what I could do is I could do negative 2 times log base 3 of 9 plus 4. And so this is really negative 2 times, and the log base 3 of 9, well, 3 to what power is 9 is just 2, and plus 4. And then this just becomes negative 2 plus 2 plus 4, which is 0. So then our coordinate would be, our y value would be 0. But the question becomes, is right before this step, negative 2 log base 3 minus 1, what's the x value that goes in here to make all this equal to 9? And that x value is 10. So when x is 10, then I get a y value of 0. And that'll be my last coordinate that I'll use. So 4, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 comma 0. So my function is looking something like that. And this is going higher and higher and higher. Right, so that's getting 3 coordinates there on this graph. Right, so again, we're emphasizing these first 3 properties that I showed you. Those are, the first 2 get you really 2 nice easy coordinates. The third one gets you your vertical asymptote. And again, if your teacher's asking for 1 or 2 more, then try to get this log base b to be, again, if it's log 3, log base 3, then think about 3 to the first, 3 to the second, 3 to the third. If this was log base 4, hypothetically, if this was log base 4 of x minus 1, then I'm thinking to myself, what's 4 to the first? 4 squared, 4 cubed, right? And these are the numbers I would want. This is where I would replace that with 16, and what gives me 16, and so on. All right, so it all just depends on the base there. Hopefully this helps. See you on the next one.